Welcome to CS288W. I'm instructor Robert McMillen, and we are on our Module 2 presentation. So Module 2 is going to cover some different objectives. We've got a lot of TCPIP, a lot of internet addressing. Also going to talk about IP version 6 and how that applies to our labs, and how to configure different TCPIP networking. So we did do some of this in the 279 class, but this definitely expands onto this, especially with the version 6. So besides giving hints to quiz questions, we'll also be going over the lab itself and doing a walkthrough on that. So stay tuned because that'll be really helpful. All right, so TCPIP, it's a protocol suite consisting of transmission control protocol and internet protocol. So basically, internet protocol is the car and TCP is the driver. And the reason we say that is because you can actually have a lot of drivers in the car, in the IP car. You could have UDP, you could have GRE, you could have a whole bunch of different protocols that sit on top of IP. Now, TCP, of all the different protocols, TCP is a connection-oriented protocol, which basically means if the connection isn't made, it will resend or retransmit the packets, whereas UDP is a connectionless protocol, and it will not try to resend the packets if it doesn't reach its destination. So there's advantages and disadvantages. TCP is going to be slower than UDP. Network discovery, that is a setting that is in all modern Windows operating systems that allows you to browse to all other computers. Now, in earlier versions of Windows, you had this turned on by default, but you may not want that because it does add a lot of overhead network traffic. So when you do go to your network it used to be called Network Neighborhood, but now it's just called Network, in Windows Explorer, then you will be given the option to browse to your other computers or not. You can turn that service on or not. And when you do connect your network card for the first time, you're also going to get a message that pops up and says, hey, is this a public network? Is this a domain network, if you remember the domain? Or is it a private network? And you're going to, you can see these different things in this particular slide that tell you what all those mean. But basically, if you choose public, it's going to have the most amount of firewall ports blocking traffic to protect you. Whereas if you choose work or domain, it's going to have the most ports open to allow you to get work done in an area that you believe is a trusted network. So that's the basic difference between those. The next generation of TCP/IP has lots of different enhancements. Automatic dead gateway retry. It ensures an unreachable gateway is checked periodically to determine whether it has become available. Compound TCP, which optimizes TP transfers. TCP statistics. It helps determine whether performance bottlenecks, see if there's a bottleneck in the network. Neighbor unreachability detection for IP version 4 determines when neighboring nodes and routers are no longer reachable and reports that condition back to you. It says, hey, I can't get there. Other enhancements that are for IP version 6, you've got for DHCP version 6, it extends the DHCP client to support IPv6 and allows stateful address auto configuration. So if you can't reach a DHCP server, it will automatically go ahead and do a private IP, just like version 4 does as well. It also has security, which IPv4 has none of that. It allows use of IKE and data encryption for IPv6, so it can actually encrypt the data stream. IPv6 point-to-point protocol allows native IP version 6 traffic to be sent over PPP-based connections. And you've got LLMNR. It allows IP version 6 hosts on a single subnet without a DNS server to resolve each other's names. So that was one of the biggest problems with the prior version, was that if you didn't have a DNS server, you could not resolve names to IP addresses. But now with LLMNR, which is built into that, into this version of TCP/IP, it will automatically start resolving names to IP addresses without a DNS server. So if you recall from the previous class, an IP version 4 is a 32-bit logical address that has a network address and a node address. So on the left-hand side is the network, and on the right-hand side is the node, or the host. IPv4 addresses are divided into 4 8-bit values. So that's pretty easy. You've got 192.168.0.5. Okay, so that's you've got different octets is what that's called. And each of those octets, the reason they're called octets is because they're 8-bit values. You've got 3 different ways to send out an IP version 4 address. You've got Unicast, you've got multicast, and you've got broadcast. So Unicast assigns the individual network interfaces that are attached to an IPv4 network and are used in one-to-one communication. So that's our basic one-to-one communication type of connection. Multicast addresses for which one or multiple IP version 4 nodes can listen on the same or different network segments and are used in one-to-many communications. And you could do basically a multicast where one server maybe has a video running, and you can connect to a whole bunch of different computers at once that they can all see that video at the same time. That would be one form of multicast. That's pretty popular. Broadcast is designed to be used by every IPv4 node on a particular network segment and used for one-to-everyone communication. So basically the computer itself broadcasts out and says, hey, where is everybody? Instead of multicast, which is the opposite. Broadcast does one to everybody. All right, so these 3 slides basically just cover what I just said, so we'll just go ahead and move on. Network address translation. A network or NAT device is what it's also called, such as a router, is responsible for translating private addresses to public addresses. So allows nodes on the internal network to communicate with nodes on the public internet. So my computer, for instance, is going to be on a private network. So if I do an IP config, we can see that my address here is 192.168.15.2. So if I go out to the internet, and whoop, looks like I spelled that wrong. Let's try that again. There we go. And I say, hey, what's my IP? And it says, hey, my IP address is 73.11.65, but I thought my IP address was 192.168. Well, there's something that's translating my private IP address to the public IP address to protect my internal network, and that is network address translation. And what's doing that is my Comcast modem. So my modem is not just a modem, it's also a router and a firewall which has NAT built into it. So that is what's happening, and that's how it protects you. So we also have classful and non-classful networks, which is a quiz alert. And a classful network is a network that follows the class rules A, B, and C. A classful network is a network that doesn't strictly follow the rules. Non-classful networks might have subnets that don't follow the normal rules for network and host IDs. So if we go back to our example here, we can see 192.168.15.2, and our subnet mask is 255.255.255.0. So by definition, anything in the 192 range is going to be a Class C network, so my subnet mask should be 255.255.255.0. However, if I said, you know what, I need to have a lot more hosts and I don't need that many networks, and I'm just going to say 255.255.0.0, now I've taken a Class B subnet mask and I've applied it to a Class C IP address. So what does that turn it into? Well, turns it into a non-classful network because I didn't follow the rules. And it doesn't matter. You don't have to follow the rules. It'll work just fine. They also call this, in the Cisco world, they call them classless. Broadcast types. When you broadcast out, is one of the types of sending traffic we mentioned earlier. There's a few different ways to do it. There's network broadcasts, which is used to send packets to all nodes on a class-full network, so a network that follows the rules. Subnet broadcasts. This is used to send packets to all nodes on a non-classful or a classless network. And you have limited broadcasts, which is used to send packets to all nodes when the network ID is unknown. Subnets and subnet masks. A subnet is a portion of a network that operates as a separate network. Logically, it exists separate from the other networks. All right, so if we go back to our example here, we see 255, 255, 255, and then .0. So basically, anything to the left of these 3 octets, because you've got this 3 octet subnet mask, right? So anything to the left here, that's 3 octets. The first 3 octets are the network, whereas this 0 represents the hosts. So my .2 is the host. So all that means is in order for my computer to communicate with your computer, you have to be on a 192.168.15 subnet. But you cannot have the same host address. So you can be .3, you could be .4, you could be .5, all the way through 254. That's all that means. So if I change this to 255.255.00, then only the first 2 octets are the network. And that means I can have anything I want over on this side. I could be 0.1, I could be 10.20, I could be 50.100. It doesn't matter what it is, as long as it's no higher than 255, of course. Anything to the right of the 192.168 would be my host address. And you have to be something different than my address. You can be anything you want, but it's got to be different than my address, because you can't have 2 of the same host addresses. And of course, if I just went to 255.000, then only the 192 has to be the same in order for you to communicate with me. And then you could be anything you want after that. So let's talk about IP version 6 for a minute. So if you recall, IP version 4 is a 32-bit address, and so you have 4 billion addresses. Whereas IP version 6 is a 128-bit address, and it allows 2 to the power of 128, or a lot of addresses. So if you divide this by 7 billion people, actually there's a lot more zeros than you think here. If you divide this by 7 billion people, then you get something like 80 trillion addresses per person. So it's not likely that we'll ever run out of addresses. But they thought that same thing when they came up with IP version 4, when it only had 4 billion addresses. They thought, oh, we'll never run out of those. But of course they were wrong. So maybe I'm wrong here. Who knows? So IP version 6 addresses are divided into 8 16 blocks delimited by colons. So you see a colon between every 2 digits. With standard Unicast IP version 6 address, the first 64 bits represents the network ID, and then the last 64 bit is the network interface, or the host ID. So it follows kind of the same rules as version 4. The left side is the network and the right side are the hosts. So here's an example of a version 6, IP version 6 address. And if you wanted to, you could take, anytime you have a 0, all zeros, you could take and just represent them as just a single 0. You can also express these contiguous set of 0 blocks as 2 colons. So basically you can really shorten this thing up by going with colon colon, which just assumes that there's just nothing there. And the loopback address, if you remember, in version 4 is 127.0.0.1, but in version 6 it's just all zeros and then a 1. And this could also be represented as colon, 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 1. So you don't even have to put all those zeros in if you don't want to. If you see an address that begins with FF00, that's used for multicast transmissions. So it's not a real IP address, it's just a multicast address. So you can't assign that to your computer. Link local unicast addresses. This is very similar to the auto IP called APIPA in version 4, where you see an address start with a 169. Well, version 6 is the same kind of thing. It's called link local unicast addresses. So if it starts off here, each IP version 6 address is assigned a different prefix length. You've got FE01, 1234, and then /48. So we're not going to get that deep into version 6, but there are a few quiz questions that are covered on this slide and the last couple of slides. So when you get to that point, it is an open book test. You can take a look at this, and it'll help you out. ISATAP, Intra-Site Automatic Tunnel Addressing Protocol. Provides a way for computers to communicate using IP version 6 over an IP version 4 network. So if you have an IP version 4 network, but you want to get out to, say, a website that's on version 6, a lot of websites that are in Asia are already using IP version 6. Also, our cellular network, even in the United States, is using IP version 6. If you look at your public IP address, or you look at your IP address on your phone, you'll see it looks just like an IP version 6 address rather than a 4, because we have run out of those addresses quite a while ago. So basically what this is saying is you can be on an IP version 4 and you can get to an IP version 6 website because of ISOTAP. Does a nice translation for you. Another translation protocol is the 6-to-4. It's a client-side mechanism designed to allow IP version 6 capable hosts, such as your URA clients. Now, URA is Universal Remote Access. It's a type of VPN that came out in Server 2012. We won't be using URA, but there will be a few quiz questions on that technology. So keep in mind these slides when you see those. So a component of the operating system in the form of a virtual network adapter. So when you use version 4 and you want to go to version 6, it creates a virtual adapter that allows that conversion to happen. Torito, it's also a universal remote access client technology, uses a virtual network card and encapsulates the IP version 6 packets within the IP version 4, so that way they can communicate. So Torito, 6-to-4, ISOTAP, they can all work together to translate between your version 4 and your version 6. So we covered all those good objectives that we talked about earlier. Let's move on to our lab. So the first thing we want to do is we want to go into our router 1 to make a change. So this is going to be a really cool lab. We're going to turn our router 01 server into a true router. So as we mentioned earlier, when we set IP addresses up on DCO1 and client, they're the 192.168 addresses. Well, once we set those, you could no longer reach the internet. So what we're going to do is we're going to turn our router server into a router where we will pass our traffic from DCO1 through our router server right out to the internet. And first thing we want to do is go into router 01 settings, and let's get to the right one. Here we are. So there's our router 01. You have to have already installed Windows on it. So we're just going to assume that you did that. Right click and choose settings. And you can see we have a network card, and we earlier changed this LAN segment to LAN segment 1 where it was used to be NAT. So that way we could communicate between the 3 different servers, or 2 servers in the client. So what we're going to do is click on Add, and we're going to choose a network adapter. And next, and we're going to say NAT, which is fine. And power it, connect it, power on. So if we switch back to our document here, we just did all these steps right here. Now we're going to go ahead and boot up router 01, and we're going to open up the network sharing and change the adapter settings. So let's go ahead and do that. Let's start up router 01. All right, let's log in. So remember, this is the one device that is not a member of the domain yet. So let's go back to here, and we're going to say that the new network card, we're going to change that to be called WAN, and we're going to call the other network card LAN. So we're going to have a pass-through here. So you need a network card on the inside of the network to share with DCO1 and client, and you need a network card on the outside of the network as well. So let's take a look at what Ethernet 0 says. And this says 192.168.0.1. Okay, so we know this is our LAN, a local area network. So let's rename it to LAN. That makes our other one, because it's going to be set to automatic, our WAN one. Let's make sure that it has an IP address. So let's go to status, and we can go to details, and we see 192.168.213.133. So that's not the same subnet, so we know that that's the right one. So let's rename that guy WAN, because that's our way out to the internet. All right, so now let's make sure you get a screenshot of that for the lab. Now let's go ahead and open up Internet Explorer and just make sure that the internet works before we move on. All right, ask me later. So let's go ahead and put in website. Now, if you don't get it to come up, some of you it'll just work right away, but others it may end up saying, hey, I can't find that page. That's okay, because this doesn't happen all the time, and I'm glad it happened here, just for example purposes. But what's happening is it's using the DNS server on the LAN, which was 192.168.0.5, but if you recall, that DNS server doesn't yet have access to the internet. So that's not going to work. So what we're going to do is go into the, on the WAN side, and let's just go ahead and put in a public address on that one, which we'll use all 8s for Google. And we'll hit stop. And there we go. So now we got to come up. Actually, it looks like CNN's website, it just happens to be down right now, which is what part of my problem was. But you get the idea. Just in case you run into that problem, you can manually put in a DNS server and get that to go. And we can change that back at a future time if we want. So the good news is that we seem to be on the internet now on router 01. And I hate adding these stupid things, but I just don't want to go through the effort of turning that off right now. So we'll just go ahead and add, and there we go. So there's our news. So let's close. There we go. We're all closed up now. So now we're going to go ahead and install routing and remote access services on router 01. So we're going to add that as a role and a feature. All right, we're going to add click the Add Roles and Features button. Next. There's our router. Next. And we're going to click on Remote Access. It's going to pop up a little message here. There we go. It didn't pop up that time, but that's okay. If it does, just click Add Features if needed. All right, so we're going to leave the features part alone. And we'll choose Next. And here's the important part. Make sure you check only the routing box and then add features to that. Okay, it'll automatically check the RAS, which is fine, but this is the one we want to click. And install. And again, could take a few minutes to go. Just let it give it some time to go ahead and finish, and we'll fast forward. Okay, it's all finished. Now we should see a new option under Tools, and we're going to go ahead and open up Routing and Remote Access. So that was not there before, but it is now. So let's go ahead and open that. And you'll see it's turned off by default. So let's right-click on it and choose Configure and Enable. Next. All right, so here's the tricky part. So make sure you check the right box here. We want to just check Network Address Translation. If you choose the wrong one, you're going to have a problem. And we're going to, we have to pick which interface we want this to happen. And this is the WAN interface. That's the one we want to happen. And finish. And it's going to want to start the service, which of course you'll want that to happen. If it still doesn't start, then we have to troubleshoot it. All right, so now this computer is going to take traffic from DC01, pass it through the LAN connection on router 01, then pass it through the WAN connection out to the internet. So let's test it out and make sure it works. All right, if you recall, on our DC01, we did not have internet access after we assigned the IP address of 192.168.0.5. So we lost that internet access. But our gateway is .1, which is our router 01, right? So now if we try to ping 8.8.8.8, if our setup was correct and router 01 is now going to route our traffic properly, we should see a response. And we do. So we are now going from DC01 into the router out to the internet. And it's doing our network translation for us. And just for fun, let's go ahead and go to Internet Explorer on DC01 and just confirm that we can see a website. Now, if you don't get a website, that's okay. We're going to go in and make a change. For some people, this will work right away, and for other people, it won't. So let me show you what to do. So let's go to Tools, DNS, and we'll set up what's called a forwarder. So we've got our forward lookup zones, and it just covers the .internal domain. But what we want to do is we want to say, hey, if you can't reach what you want internally, send it out through this forwarder. So let's go ahead and delete the default 192.168.0.1 address and replace it with 8.8.8.8, which we know is Google's DNS. You don't have to worry about it if it resolves or not. It will eventually. And we'll go ahead and apply that. All right, so now we'll go back, and looks like it's already working. And now it is. There we go. So that's what you do if you don't get access to it right away. Just go ahead and add in that forwarder, which is something you want to do in real life anyway. That is a normal thing you want to do as an IT administrator, is set up the forwarder in DNS. So we're in good shape now. So we're definitely accessing that. So we want to do the same thing from the client. You'll want to go in and let's go back to our lab here. Go in from the client and make sure you get access to the internet as well. So here we are on our test internet connectivity on client. So I'm not going to do that here, but go ahead and start up client. Make sure you get access to the internet. And if it works from DC01, you should have no problem getting it to work from client, since it uses DC01 and router 01 to get out to the internet. DC01 for the name resolution referral, the forwarders, and router 01 for the actual access out to the internet. All right, so the next thing you want to do is to provide a screenshot of your IP configuration settings just to confirm that you have them right. So if we go back to, let's just take a look at DC01. What you're going to do is you're going to do a screenshot of the IP config. So do IP config /all, just like that. Hit enter, and it shows you the IP address, the subnet mask, the gateway, and all the other information. So just go ahead and screenshot this box, and that's what you'll use when you provide a screenshot of the IP configuration for 4 and 5. So DC01 and client. So that way we know for sure that you set that up right. So we've got generate a network configuration diagnostic report. This will only take you a couple of minutes. I'm not going to show you how to do it because it walks you through here step by step, and I've never had anybody have any problem with it. So what you do is just follow these directions, and on your router 01. And so there it is, router 01, log in as widget LLC /administrator, and run this report. Now save this as an HTML file and submit it as a second file when you submit your lab. So your lab should be on one document, and this HTML report should be on another document. So don't try to paste it into your lab, because it's going to be a huge report, and it makes it very difficult to scale through. All right, so you've so your deliverable 6 is to submit the file. Deliverable 7 is you're going to define what these different commands mean. They're going to be very useful to you as an IT administrator, so I want to make sure you understand what those mean. Then you have deliverable 8, which is what sections of the report would you use to determine if IP version 6 is installed. So go back to that HTML report you created earlier and try to find where IP version 6 is, so how you know that it's installed, and how does it identify IP version 6. Just copy and paste that into deliverable 8, and then I'll know that you found out where that was. And then there's a couple of questions for lab reflection and knowledge adaptation. So you'll provide me a couple of paragraphs for that, and that will cover Module 2.